Hi there, welcome to another Richmond School District Numeracy Burst session. This series is focused on inclusive practices in mathematics. This particular session is focused on kindergarten through grade 5 and the mathematical idea of representation. There's a complementary series going on alongside of this series for grades 6 to 9 inclusive practices in mathematics as well. My name is Janice Nowakowski, and I'll be hosting this session. I'm a district teacher consultant for K-12 mathematics and numeracy in the Richmond School District. When we think about inclusive practices in mathematics, we draw upon the work of universal design for learning, as well as culturally responsive pedagogies. And so beginning in mathematics, we want to nurture belonging and community for all students. And welcome them to mathematics. We want to build on students' funds of knowledge and the strengths that they bring from their families and homes, their home languages, their culture, their community, and also to build on their interests, what they're curious about, what they like to be engaged with, and use those as entry points for mathematics. Drawing upon UDL, as educators, we want to make sure we present and represent mathematical ideas in different ways and through different modalities when teaching. So oral language, written language, pictures, gestures, concrete materials, presenting and teaching through different modalities. We want to create opportunities for choices for students for where and with who they learn and think with. We want to create choices for children's choice of materials, tasks, the range of numbers that they choose from, and then access to tools and technology as well. We want to create choices for different ways for students to represent and to share their learning. And again, by providing choices, we create agency for our students and empowerment and engagement. So universal design for learning has some core ideas. That idea of variability, that we accept learners' variability as the rule, not the exception. We know we're going to have a range of learners and types of learning, types of experiences that students want and need in our classrooms. We are going to have firm goals, but flexible ways of reaching those goals. So everyone has a firm goal as a class. We're all learning about this, and then individual students or small groups of students might have then sub goals around that, but that we have flexible different ways to get towards those goals in terms of choices, different types of tasks and learning experiences. And then we want to support and nurture learner agency. We're removing bias and barriers for our students, and we're creating opportunities for them to actively make choices about their learning. So again, when we think about this, this is drawing upon a current work from Katie Novak and Ashley Marlowe around UDL and mathematics specifically, thinking about multiple means of engagement. So how do you ensure that all students participate in welcoming, inclusive number sets routines? So if you open your lesson, how are you creating access points for all students and that they feel welcomed to mathematics? That we're providing multiple means of representation. So as the teacher, how are we facilitating meaning making of mathematics through those multiple models that we're sharing? When we say 10, are we holding up 10 fingers while we're saying that? Do we have a 10 frame on the board behind us? Do we have another visual representation or pictorial representation of 10 to go along with the written word, the symbolic word, and the oral word? So all those multimodalities when we're teaching. And then multiple means of action and expression. How do you choose the materials and activities to encourage students to take ownership of their learning and express their thinking in their own way? So what tools and technology and materials are available for students to express and take action around their learning in mathematics? So again, these are some of the key resources that we've drawn upon for this series. Rachel Lambert's work on rethinking disability in mathematics, universal design for learning in mathematics, cultivating mathematical hearts, and then culturally relevant mathematics tasks. There's a K-5 and a 6-12 book for that particular one. So when we think about representation in mathematics, specifically, we can think about three different types of representation. We can think about how students are represented in the materials, the resources, and the context that we use in the classroom. We can think about, as teachers and educators, how we present different representations and through those different modalities when teaching, and then how students can represent their mathematical ideas and thinking in different forms. So in terms of representing students and making them feel like they belong and are included in mathematics, that can be as simple as making sure that the books and the materials and the resources that we use include students that look like those in our classrooms, but also students from the broader community and from the world. And so that we're opening those windows and doors, as well as having students' own identities reflected through mirrors in the books and the resources that we choose. So on the left, you can see, at the time of this recording, it's during Lunar New Year, and having some books out about Lunar New Year that children who celebrate Lunar New Year can relate to and connect to. I've got some little dumplings there and steam baskets and creating numeracy tasks with context that will be familiar for many of our children. You can see the mathematics bookshelves in the math studio here in Richmond, and making sure that we have gender representation and different cultural representations and language representations as well, including local Indigenous cultures and languages. And then on the right, just some dice where we have the different symbols for different numbers in different languages. And so many children come into the studio and can't believe that I have dice that have kanji on them or the different symbols from their languages. And then on the bottom right, I try and find and collect books that come in multiple languages, again, for students to engage with, and especially, students that are new, whether they're refugees or have joined, our community here in Richmond, where can they access some of the ideas that we're talking about in their home languages as well. And then in the bottom center there, this is again from one of those numeracy tasks that from a kindergarten class where we were talking about sharing dumplings and how you might share them with your family members. And, this student drew a dim sum table and all the chairs around it and all the dumplings and the hungry mouth and, how many would go to each person. And so a context that felt really familiar and comfortable for them through that problem solving experience. So this is from the work of the National Council of Teachers of Mathematics, the NCTM. Dr. Francis Fennell or Skip Fennell talks about the importance of representation in mathematics. So the process of representation includes using models to organize, record, and communicate mathematical ideas, as well as selecting, applying, and translating these models to solve problems and interpret mathematics. The models can be used to show math through the use of manipulative materials, diagrams, graphical displays, and symbolic expressions. So as students get to grade 4 and 5, we're starting to see tables and charts and other ways to organize data and information that they can then graph or interpret in different ways. We have students recording their thinking using pictures, numbers, and words when they're younger as a way to encourage them and nudge them to show their mathematical thinking using different symbols, using words, using pictures, and tools like 10 frames or open number lines. So as educators, when we're planning for learning and designing for learning, it should be representation should be something that we're thinking about. So what model or material or representation, matches with this sort of topic or competency that I'm developing with my students? And then thinking about representation and teaching some more, again, from the work of NCTM, what models work for certain age groups or for certain topics? Are these always the best model? And so using our understanding of the mathematics and the age of students we're working with, making those really intentional choices about representations in terms of how we record their thinking as teachers, as well as what tools and materials we offer to students to choose how they represent their thinking. So here's some examples from some number talks, math talks that I've done with some classes. On the left side here, we were doing a sharing numeracy task in a kindergarten class around sharing 6 bao or dumplings, and having the students, I showed 2 different containers. They each had 3. So how do they know how many there are altogether? And this is me recording the way the students explain their thinking. And so I've used some of their words, some of their language, some of the gestures that they used. I tried to capture that using drawings and numbers and symbols and arrows and that type of thing. So that's one type of representation. On the top right, you see a number talk. This was in a grade 2-3 class. On the left, I'm recording the different language that's coming up to help build their vocabulary. And then you can see I've used an open number line as a visual tool for them to connect to the strategies of adding on to subtract. We've got the 10 frames up there as an anchor tool as well for them to see. We started with 14 and then moved to 54 in our equation. So again, those different visuals and representations that help them understand the mathematics. And then on the bottom right, math talk, same but different. So we have the visual of the two squares that are decomposed in different ways into fractional parts, and then the language and the symbols that is also making a connection to those representations. And then, of course, representation and assessment. Representation is one of our curricular competencies from K to 12. So we're assessing that across the grades. And so again, some of those questions that might nudge students in thinking about how to show what they know and how to represent in different ways and how we might assess that. So how are students using representations to model and interpret the mathematics that we're presenting? How is the student able to show through their representations their understanding of the math or the vocabulary that they understand or the concepts, and that idea of using diagrams, sketches, or equations to explain how they arrived at their solution to a problem or task. So in our BC curriculum, under the communication competencies for mathematics, we have one specifically around representation. Represent mathematical ideas in concrete, pictorial, and symbolic forms. And that language has been in our BC curriculum way back to the WNCP, or the Western and Northern Common Protocol. I can't remember the exact wording for the WNCP, but that's like from the 1990s, 1998, I believe, or 1995. And so we have always used that language of concrete, pictorial, and symbolic. Much of the math education literature uses CRA, so concrete, representational, and abstract. And the old thinking around that used to be that students move through a math idea first at the concrete stage, then the representational stage, and then move to the abstract or symbolic stage. And so regardless of what age they are, whenever they're learning a new math concept, the idea was that you start out at the concrete stage and then you move along to abstraction or using the symbols. And some of the current research around that, some of it from Dr. Kathy Marks-Kirpan out of OISE here in Canada, talks about that, there is a bit of a linear progression, but actual fluency in terms of understanding these mathematical concepts really comes when students are able to be flexible and move between all three, sort of levels or stages. So to be able to fluently move between concrete and pictorial and symbolic and back and forth across the grades and across mathematical topics. So here's some examples of how students have represented their mathematical thinking. And again, thinking about how we're giving them opportunities to practice that and opportunities to choose the different representations. So again, using materials, using pictures, numbers, words, and symbols, diagrams, charts, etc. On the left, that's a kindergarten student, and that is their representation using pictures, numbers, and words of a math problem about sharing dumplings and eating so many and then how many would be left. In the middle there, choose an addition equation and solve it in different ways. Again, using symbolic forms as well as concrete pictorial forms with the 10 frames and then the movable magnets. That was in a grade 1 and 2 class. At the top, there you've got a concept circle with the 9 in the middle. That was in a kindergarten and grade 1 class. And what are all the different concrete representations we can make using different materials, and what materials are conducive to, developing that sense of nine-ness? We've got Numicon shapes there, we've got Reckon Rex, we have two-sided counters, we have Unifix cubes, etc. Different materials that can support students' understanding. And then comparing representations is a great extension of that. So that was one of the math workshop tasks in that KN1 class. And then I took a photo of it. And for our consolidation time of the lesson, I projected the photo up on the screen and I chose two representations. I said, how are these two representations of 9 the same and how are they different, to get to that really, comparative higher level thinking and having students think about their representations. At the bottom left, or bottom center there, we have another student in grade 1 and 2 using the dice and then their symbolic representations of different equations. And then in the middle on the right there, we have students practicing a pictorial representation of adding on using that tool of the open number line. So again, choosing an equation that feels just right for them, and then representing that on the whiteboard and practicing using that tool as a representation of a mathematical strategy or process. And then on the right-hand side, you see some representations from grade 4 and 5 students. And this was a class that was visiting the studio and was just beginning to learn about fractions. So grade 4 is about comparing and ordering fractions, and grade 5 is thinking about equivalent fractions. But we were starting to see what they knew about fractions. And on the top right there, I just had different tent cards out for different fractions, and students chose from a buffet of math materials, concrete materials, and they were just creating different representations for those different fractions, which then again, of course, expanded into equivalent fractions, and we could do that sort of talk with some of those students. On the bottom right, students used these marker crayons. It can be used on the windows to show us what they knew about fractions and use different representations, pictorial and symbolic, to make that connection and bridge between pictorial and symbolic understanding. So just some examples across the grades, kindergarten through grade 5. So many of the resources to support us as we think about inclusive practices, including representations, will be included on a new tile on RichNet under the K-2, the 3-5, and the 6-7 Numeracy Foundations frameworks. The Math Workshop framework tile is above it, and then the Inclusive Practices framework tile below. The recordings from the burst sessions, the slide decks, as well as additional resources and supports will be shared there. So as we come to a close, I'd like you to just sort of pause and consider and reflect on your own professional learning and thinking about your classroom, and think about in what ways can you represent students' identities in your classroom through materials and contexts. How can you be more mindful of representing math ideas in multiple modalities during your teaching? And then what opportunities are you providing for students to represent their mathematical ideas and thinking in different forms? Thank you for joining us.